Starting from the question number one, children. Question number one from the specific heat chapter, chapter number nine, chapter number 5 of grade 9, IGCSE. Please read this statement. The water in a copper hot water tank is heated during the night. During the day, the water cools as thermal energy or heat energy passes from passes from water to the air surrounding the tank. Describe the process by which thermal energy is transferred from the hot water to the air. Yes, children. Water is there in a copper. Hot water tank is heated during the night. During daytime, temperature is losing. What is happening? The process by
So
which
it's convection.
Convection.
Convection. Yeah.
through by convection you are saying. Uh, Describe the process by which the thermal energy is transferred from the hot water to the air. That you have to explain the process by which that the hot water is losing its energy and it is now cooling in daytime.
It could be the fact that as the water gets heated during the night, it starts evaporating. And because of that, it starts doing the convection current where the warmer water vapor rises. It gives way to the cooler parts of the air. I'm not too sure though.
Yes, okay. Now, children, that first you need to try to understand the meaning of this statement. Water is there already, hot water is there during the night time. But during the daytime, they said that now the water is losing its energy and it is temperature is decreasing as it cools, as thermal energy passes from the water to the air or the surroundings. What is happening here? So the first method we can say that evaporation will be there. Hot water is there, evaporations can take place, and during the evaporations, high energy particles they leave, and the remaining or the average kinetic energy of the remaining liquid decreases and the temperature falls. So slowly and slowly that the evaporation is taking place. Second point you can say, as it is a copper vessel, as it is a copper tank, so copper is the best conductor, maybe the container get heated, the walls get heated, and in terms of radiation that some heat energy may be lost due to the conduction process or through the emission of radiations from the copper side of the container. So that point I can add here, some energy loss, some heat loss or energy loss from the walls. If you find any other suitable points, you can also add it here in this question. I want to move to the next part, children. State why the rate at which thermal energy passes into the air decreases as the water temperature falls. Means that the rate of thermal energy loss, it decreases as the time passes. What will be your explanation for this point, children? This happens actually.
There's a reason why the water temperature falls. It means that it had already lost some thermal energy. So as the temperature of the water continuously falls, that means there would be less thermal energy that passes into the air at a lower rate. Is it like that, sir?
Okay, now here one thing I want to add in this point, and for this second part, children. Initially, that the vessel was hot, the water was very hot, and we know from that the concept which we have learned in this chapter, heat always from a body at high temperature to a body at low temperature. And higher the temperature difference, that the greater is the rate of evaporations, or sorry, rate of losing heat. System, that is a copper vessel filled with hot water, and the surrounding, there is a huge temperature difference in the beginning. So the rate of the cooling will be faster. But as soon as the time passes, due to the evaporations process, thermal laws, any other methods which we can put here for the question number one first part. So due to that, there is a less difference in temperature with the system as well as with the surrounding, so that the rate of cooling will slow down. Second point, in terms of evaporations, high energy particle, they escaped out. High energy particle, now the temperature of the system already has reduced to a certain amount, and now as it is reduced, evaporation process may also slow down, because the surrounding temperature and the temperature with the system is now not with a large difference. Any other children that you want to add for question number one second? Gayatri, Chiara, Ayush.
No, sir.
No, okay, so let's move to the other question now. In B part, the manufacturer of the hot water tank says that when the outside surface is polished regularly and kept bright and shiny, the hot water will cool more slowly. Describe with the aid of a diagram an experiment that shows whether a container with a bright and shiny surface is better at keeping its content warm than one with a full dark surface. Now, how will you describe this process, children?
Uh,
Hmm.
a dull black substance kind of tend to absorb light more, like sunlight more, but like a surface with like a shiny or a white paint, it might actually like reflect. It has a better reflection rate, so that it won't actually kind of uh, it won't actually like.
Mhm.
Oh wait, I guess I'm wrong. I guess the paint just. I guess the paint is an insulator, so that they won't actually like kind of let the temperature escape, so the hot water cools less.
Mhm. Sneha?
So it wasn't like in our textbook. I remember seeing something like emitters and absorbers. So then there's one like white silver surface with the light and like
Now, now
what
what you can do actually, children, so you can, what you can do, suppose this is that container, copper container, and in one of the experiment they said it is regularly polished with a shiny surface. Hot water is there, and we can measure the temp. We can put a thermometer, and we can notice out that how the heat is losing through this kind of when the sides are well. The second case, that the same container, but now it's paint black. Sides are paint black. Black body, again, we can measure the temperature by putting a thermometer, in which case that the rate of cooling is faster. We can predict with the help of the thermometer and by noticing the temperature for a small period of time. But as we know the concept of physics, that black body is the best emitter.
yeah,
Absorber
with the
as well
best
as,
absorbers.
yes. If it is a best emitter, best emitter. So it means the hot water is there, so it will emit the radiations faster, and the water will cool faster. But what is the our question? Uh, Manufacturer of the hot water tank says that when the outside surface is polished regularly and kept bright and shiny, the hot water will cool more slowly. We want it more slowly that the water cool. So that's why we need a well polished shiny surface if we want to keep it cool for a longer period of time, means hot for a longer period of time. If we want to it cool faster, we can put a black surface so that the radiations, emissions of radiation will be faster. So you can have to explain this diagram. You can draw an exam, and one with the poly surface, one with the black surface, and then you can add by measuring the temperature in both the cases, and then you will find well poly surface uh, will make water cool slow or slowly as compared to the black surface. Question number two, four identical metal plates at the same temperature are laid side by side on the ground. One plate has a matte black surface, shiny black surface, matte silver surface, and the fourth one is shiny silver surface. Four different kind of materials are there. Matte black surface and matte silver surface. There is a difference in both the surfaces. Okay, and the shiny black surface and shiny silver surface. State which plate has the fastest rising temperature when the first falls on the plates.
I think
Which
it'll
plate
definitely,
has the
Matte
fastest
black.
rising temperature?
I think it'll
Fastest.
be matte black
First
surface.
one.
Yeah, the matte
Matte
black
black.
Yeah,
as
matte black.
it absorbs the
Yes.
The color black, it absorbs temperature and heat, light, and
More.
it's matte, so it does not somehow reflect
Hmm.
any light.
Yes. Correct.
Sir,
Yes, please. Mhm.
if matte black surfaces like if the temperature like rise fast, like I know this isn't like an unrelated question, but like do you know Vanta black, like the paint that absorbs 99% light? Does that also like heat fast? Does that also like heat up fast when sunlight hits it?
Yeah, that when the body is or the surface is completely black, a matte black surface, it will absorb more and more radiations. Most radiations is absorbed by it, and due to that, the temperature of the body will increases because none of the part is reflected. A black body is a best absorber. It is a best emitter, but it is a poor reflector. It is a very poor reflector of light. So here, as we are talking about the increase in temperature, it will absorb the radiations. So that's why what surface? Matte black. Even if we compare, what about the shiny black surface? Surface is black, but the shiny. So shiny means that it may reflect some part of the incident radiations. So better surface is a matte black surface. Shall I move to the second part, children? Or you want to discuss some more about it? Vansh? No.
Yes,
Okay.
sir.
Okay, so let's move to the B part. The apparatus is there. Look at this diagram 4.1. This is also important question, children. This is known as Leslie's differential air thermometer. You can search in Google what is this experiment actually. What was the Leslie's experiment? And a diagram you can see what we have in this diagram. On the left hand side, you can see a glass bulb. Glass bulb is there and glass bulb is there both sides. But the property and the nature is different. One is painted black and the other is painted shiny. Okay. And in the center of this bulb, glass bulb, there is a heat device. A heater is there. Like some kind of switch is here. T. Air is filled here in this space. Air is there. and liquid is also there. Suppose water is there. This diagram is here. And now what we have to do in this question. The heater is switched off, tap T, this T is a tap, is open so that air on the two sides of T has the same pressure. Okay, initially that at the beginning of the experiment, they just open the tap T so that there is a circulation of air, and in both the sides that the same amount or same of volume of air will be there. Now after that, tap T is then closed, and then heater is switched on. Heater is now switched on, children. On figure 4.1, mark clearly where the two liquid levels might be a short time later. Okay, and explain your answer to B1. So I will do both questions together, children, 1 and 2. And I hope that you are able to understand the meaning of this question. Heater is switched on, mark clearly where the two liquid levels might be after a short period of time. Liquid level is there in this tube. So basically the question is they are looking for whether the water level will rise upward to the black side or it may move upward to the right side. That we have to find out, children, with proper explanation. What happens actually? Now, as they said, let me explain first, children. And now heater is there, and heater is placed exactly in between the center of this system. Means distance of heater is same from the black body as well as from the Chinese surface. And so radiations are going in all directions. Both the objects, now what happens, children? Radiations which are going towards the radiations, photons, light, which are moving toward the shiny glass bulb, they reflect it back. Because the glass bulb, a shiny glass bulb, a shiny surface of property, it reflects the light. It's a best reflector. So if it is a best reflector, that the radiations are not absorbed by it, reflected by the glass, shiny glass bulb. So the temperature is not increasing too much towards the shiny glass bulb. Temperature remains low. I will write here low temperature. Nothing will happen with this shiny glass bulb. Maybe slight temperature increases, but we can neglect that one. But think about the radiations, because the same radiations are going to the other side also. And other side we have a glass bulb painted black, and we already know black body absorb radiations. As it is absorbing radiations now, children, definitely its temperature will increase. We can measure the temperature by putting a thermometer there. Now, come to the point that the temperature in this side towards the black surface is increasing. Now, due to the effect of the increase in temperature, and the air which is here, in this region that we have air, AIR. And due to the temperature increase in the glass bulb side, air expand that we already discussed in the chapter number 5. Due to the high temperature, air will expand, volume increase, density decrease. So the air will expand here, children. That's the main thing. Expansions of air is taking place. That is the very important point. If air is expanding, where it will move? In what direction it will move? The air is expanding, children. Tell me. Where it will go? Air is expanding. If the air is expanding now, children, here it is a hard surface. Sides are hard, but the expanding air will exert a force or a pressure on the liquid in this tube. It will exert force on the cross-sectional area of this tube. So basically, I can say that it will exert a pressure. Due to expanding air, exert a pressure on the left limb, LIM, left side of the tube, and Due to that, the liquid level move downward. So water level will move downward in the left hand side, and in the same amount that the liquid level will rise on the other side. So this will happen. Children, I explained, I have given the answer of both the part B I B 2, that in the left side water level fall down, on the other side it will rise, and the reason is that due to the expansions of air, expanding air will exert a pressure, and due to that pressure liquid level will fall down towards the black side.
Also, we're gonna focus on the air as well when answering this question. Yes, sir.
Kezia, please repeat.
Also, like when we're answering these types of questions, we also have to focus on other components like the air, right?
Yeah.
Okay.
Now I want to hear from ninth class student that any other children can explain if you have another kind of explanation. And Lee, Guan Lee, and Sierra, Yoma, Arsh. Is Ibrahim here? Arya
Yeah.
Academy.
Yes, I he's
Ibrahim.
here.
So if you, Ibrahim, I want to hear from you. If you don't know other explanation, but just explain that the concept which I told just now. Please explain how the level in the left side will fall down. Please explain, Ibrahim. No response. Okay. So I want to hear from Anasuya Verma. Yes, please. Please explain it.
Yes, sir.
Explain why the water level towards the glass bulb painted black fall down.
Sir, can you type and tell? I
I'm
can't
passing this
do it.
question to Arshdeep Kaur. Arsh, can you explain? Arshdeep. Are you
Yes, sir.
listening? Yeah, please.
Yes,
Arsh,
sir.
explain.
So the left side, more heat is absorbed. That's why the temperature rises faster.
Mhm. Then why the liquid level fall to the left side?
Because of the expansion of the air,
Yes, correct. Then what expanding air will do with the water? Sneha, what expanding air will do with the water?
So won't like the liquid levels rise?
Rise? Where?
No, wait, no. If the air expands,
Hmm.
the liquid levels will fall definitely because it will like push on it.
Kezia, why the liquid level fall?
Okay, because the matte black glass bulb absorbs more heat that will make the air expand. And when air is expanding, it means that it has more kinetic energy to move around, which exerts a certain pressure on the liquid, and therefore the liquid will fall. Well, I wouldn't say fall, but it will, the pressure of the air will make the liquid fall. And on the right side, where the light is reflected off, the heat is reflected off and not exactly absorbed, the liquid levels will rise on the right side. On the left side, it will fall.
Yeah, okay. So that explanation should be expanding air will exert a pressure. That is an important point here. Due to that, you can see the difference in the liquid level in the tube. Ninth class students, please, everybody, listen carefully. Listen to me, children. And even you can also make your notes for these explanations. Okay, then this is done. Next question number third. A solar panel is mounted on the roof of a house, and figure 4.1 shows a section through part of the solar panel. Look at the diagram, please. Trapped air, water, insulating material, sunlight, copper pipe, glass sheet, metal backing sheet, painted black. All these points are important, children. So first you go through with this diagram. After that, a pump makes water. Patel, please, if you could mute yourself. A pump makes water circulate through the copper pipes. The water is heated by passing through the solar panel. Suggest why the pipes are made of copper. Where are pipes? You look at the diagram, children. Copper pipes. Why pipes are made of copper?
Because they're a good
Yeah,
conductor of
because of the
Good
high
conductors of heat.
capacity.
Water is flowing through the pipes, and the pipe are made of a copper, a best conductor, so that the heat they can conduct heat energy. So the reason for this answer, so that I'm not writing, I'm just speaking, children. The pipes are made of copper so that they conduct heat better. Second, the pipes and the metal backing sheet are painted black.
To absorb as
So
much
they
heat as
can
possible.
absorb as
Absorb
much
the
heat.
heat
Oh,
better.
wax absorbs heat.
Okay,
So
yes, correct. Just remember, children, this is a system. What system? Uh, it's a solar panel mounted on the roof of a house, shows a section through the part of the solar panel. A pump makes water circulations is there to the pipes um, that we want to heat water with the help of this solar panel system. The pipes and the metal backing sheets are painted black. There is a reason of painting black. There is a reason for using the copper uh, pipes. There is a reason for painting them black so that it can absorb most of the radiation. Then what happens if it absorbs most of the radiations? Why do we need it painted black? Again,
because the color black
To
absorbs
absorb.
heat radiation easily.
water, heat, more radiation space. Okay. Third one, an insulating material is attached to the metal backing sheet. Look at
so
where
the
it is.
radiation solar radiation emission would be reduced so that the temperature won't escape.
Yes, so that no heat is lost to the
There's
surrounding.
no heat lost and
Yes, yeah. Heat loss reduced actually. Insulating material is a poor conductor of heat, so that's why insulating material is attached there so that heat loss could be minimized. Fourth one, the presence of the glass sheet increase the energy collected by the water. Where is the glass sheet? Increase the energy collected by the water. Glass, you can see that the sunlight is falling on the glass sheet. And in the glass and the bottom system that there is a air. Why do we need this glass sheet here? The role of this glass sheet here.
To allow the sunlight to pass through so that the conduction would occur so that the water will be heated.
Yes, this is also correct. Heat can pass through, then the light is can conduct through the copper pipe and absorbed by the black body that the painted black. Any other point? One more point, children. When I ask children that the question is open to all of you, it's not about two or three children. It's for entire class. Ibrahim, could you explain? Any other point, please suggest. Try to speak, children. Okay, it's not here about that who is intelligent, who is able to give answer. Not, I'm not here to punish you. I'm here to just that you can understand this lesson, this question, children. That is our aim. Ayush, you are silent today. the role of this glass here, glass sheet.
Sir, can it be like the hot air is trapped because of the glass sheet? Is that the thing?
Like the
Yeah,
heat doesn't
glass.
escape like that.
Yes, Kezia, please continue.
For that reason, that will also mean that the air just stays there and doesn't escape quickly because
Yes.
it's also insulated.
Once the light entered through the glass sheet, that it is trapped inside, and due to the heat entered into the air, air gets warm, and again the warm air couldn't go out; it remains inside. So the temperature of the system keep increasing, and that will help to make water get heated. Even that this is the same thing about the greenhouse effect also. Let me go to the next. B is also important question. And I want to give you some time to read this question and then I will explain. I'm pausing this video for a moment. During one day, 250 kilogram, 250 kilogram water is pumped through the solar panel. The temperature of this water rises from 16 degrees Celsius to 38 degrees Celsius. So in this question, children, we have given certain amount of mass. 250 kilogram of water is there, mass of water. Initial temperature of water, EI, initial temperature is 16 degree, final temperature is 38 degrees Celsius. Certainly we need a difference in temperature, and delta T will be 38 minus 6, that is 8 minus 6, 2, 3 minus
22.
22. Okay, and now the water absorbed, heat radiations are falling. Radiation from the sun is falling on the water, whose mass is 250 kilogram. 25% of the energy falling on the solar panel is what? Absorbed by the water. And the specific heat capacity of water is given 4200 joule per kilogram degree Celsius. Calculate the energy or the light intensity, energy falling on the solar panel during that particular day. Energy falling. I will assume that Q is the amount of total energy incident, total energy or total heat incident on the water. Suppose 250 gram of water is there, heat radiations are falling, 25, some part of the radiation is absorbed by the water, increasing the temperature from 16 to 38 degrees Celsius. And then you have to find how much radiations are falling on it. So how will you do this question? You can do this question by many methods, but the one method which I know and prefer to explain to you is that the equation you have to apply here Q is equal to mc and delta. This is the equation which I have to use in this question. Mass is given, heat capacity is given, and the difference in temperature is given. That Q is the total amount of heat energy. But as per the statement, 25% of the energy. 25. So I can write Q 25% of the total energy absorbed, which is equal to mass of water 250, specific heat capacity 4200, and the delta T I already calculated here, which is 22. I need to calculate the Q, the total light radiation incident. So if I do some calculation here, this Q is equal to, I need to calculate the Q, the total energy, and 250 200 multiplied by 22 multiplied by 100 and divided by 25. You know that this part here, even you can divide in the left hand side also 25 by 100, 1 by 4. So 4 will go to the right hand side. Okay. So please someone multiply and divide by 25.
10,164,000.
Sorry, I couldn't hear.
The answer is 10,164,000.
Oh my God. KZ, can you spell east each time?
Should I repeat the answer, sir?
Yes, one by one. Each number. Each digit.
Hold up. It's 10,164,000. That's what we got.
Difficult for me to write. You type your answer in chat box.
Yeah, already, sir.
Already? Yeah. Okay, so this is 10, 1, 6, 4, and this is 0. I need to check this. Just wait.
Wait, hold up, sir. I have to recheck.
Have to do the calculation.
Yeah, it was coming 9 for
Yeah,
someone.
it's different. It's different. Yeah. Sorry. Hold on.